Uh, we will be recording this just for those of people who are not able to come tonight. I know 5:30 on Fridays sometimes is a little weird for people. So yeah, I guess we're just going to get started. People might roll in a little bit later, might not. Well, who's to say? But before we jump into sort of anything in depth, anyone's like first time here to Math Clubs? Awesome, welcome. So for those of you who have no idea who I am, I'm Nick. I'm the Math Club president. Also, we're the ones running this REU panel tonight. We will have a couple more members of the e-board joining us. One's already here, Josue. He is our event planner, event coordinator, whatever you're saying. I think event planner as the official title. And then, yeah, two will be joining shortly. They're running from their co-ops. So yeah, all that being said, if you are new, you'll notice that there's an email up on the whiteboard or Blackboard. Feel free to send an email to that address if you want to be added to our email list. Or if you're just not getting emails for some reason, feel free to fill that out or send one that way. Just really helps us. And then also QR codes, if you just joined us, feel free to scan that QR code just for attendance. And then last but not least, another piece of housekeeping. Again, those of you who have been at Math Club meetings before, we do get pizza. There will be pizza coming. It'll be arriving a little bit later tonight, about 6:15 or so. And just because of COVID and all that stuff, just being able to, we want to be able to socially separate. And if people want to leave after they've grabbed a slice of pizza, we want to sort of allow all of that to happen. Yeah, any questions before jumping to the panel or any comments or anything like that? Okay, cool. So how many of you have no idea what an REU is? Or like kind of don't know? Okay, there's a couple hands, good. Yeah, so this is why you're here, right? So as our wonderful panelists, we'll sort of talk about way more in depth later on. You know, basically an REU is just, it's a research experience for undergrads, that's really what it stands for. But the long and short of it is it's a sort of summer research project that is open to all undergraduate students. It usually they're scattered throughout the country. There's usually a host institution, and it's like an 8 to 10 week program. Usually, there's a lot of caveats here, but in general, it's an 8 to 10 week program, and it's paid. It's a paid program as well. So you go if it's in person, you go to whatever institution is hosting it. You will do research, and we'll talk about what research means a little bit, but you go and do research, and you live on campus, and you spend those 8 to 10 weeks working through whatever project it is that you might be. The really nice thing is, you know, often you'll be working with PhD students and faculty mentors during those 8 to 10 weeks. Projects may be individual, projects may be a group. It really depends on the program, and the topics that you might be talking about are wide ranging. You might be doing, might be some programs with more applied math focus. So for example, last year, there was a lot of like COVID focus, like epidemiology, modeling, that sort of stuff. But you also might have more pure math topics as well. It really depends on the programs. Hey, Sam. So I'll sort of interrupt myself just real briefly. This is Sam Lowe. He is our social chair. Also going to be moderating tonight's panel. So glad you could make it.
Yeah, I didn't oversleep this time.
Yeah. Yeah. So yeah. So obviously you're doing research, right? But you're working collaboratively. These points, these programs, they're usually about 10 to 15 people to 20. Again, it depends, but usually 10 to 20. And so even though you're working individually or as a small group, there's really a lot of opportunities for collaboration as well. There'll often be seminars, reading groups. If depending on the program, that would be like field trips, things like that on weekends. Again, it really depends on the program, but it really is trying to get you involved into whatever math research means, right? And so again, that's a very broad term. I certainly didn't know what math research was going in as a math major. And the answer is it depends, right? So maybe you are joining a project that's pre-existing, right? So maybe it's there's a faculty mentor who's doing a research project, oftentimes in applied math, right? That epidemiology modeling I talked about earlier. It might be a longer term research project and you join in, or you might be doing something new. The important thing though is research in this context isn't necessarily something that's completely new to mathematics. it's something that's completely new to you. And so maybe you get a paper published out of it. Maybe you continue it on to a full-length research project once you finish your REU. But maybe it's just you're reading through a textbook and you're trying to prove to yourself, these theorems are true or whatever the case may be. And you're sort of guided through that process, right, by your PhD students who are working in your groups and by those faculty members, mentors. So it's a really sort of great experience, again, to get the hands-on experience working collaboratively, but also in some sense individually throughout the projects. And it looks really good if you're thinking about maybe applying to grad school or wanting to do more research, during the spring or the summer or the fall, things like that. And I'm sure, again, our panelists will be able to speak more about all of those points that I just brought up. Let's see. Yeah, like I said, I'll mention again, right, these programs are paid. They are fully funded by the National Science Foundation. And so usually what that means is it's going to be, again, in general, probably on the order of $4,000 to $6,000 for your time at your REU. And if you're in person, usually housing is paid for or there's some sort of stipend involved with that. Again, it really depends on the type of program. All that being said, how the heck do you apply? And there are a lot of options. If you're in the Math Club Discord, we just posted today a list of REUs that are available. But even if you just Google, Math REU, National Science Foundation, or really just Math REU, one of the first things that come up will just be a list of programs that you can apply to. And so that's sort of great first step. Applying to REUs is exactly like applying to, or it's very similar to applying to like a grad program, where you'll often have to write a personal statement, have to write a couple supplemental essays. Really depends on the program though. And then you'll need those letters of references, usually 2 to 3, depending on the program. But again, I certainly encourage you, if you have like a specific interest, check out that list here on Google, just because you'll be able to see exactly like, oh, I'm interested in dynamical systems. These are the programs that are offering REUs in dynamical systems. So again, I just really wanted to paint a broad overview before we jump into our actual panel discussion, just so no one's like completely confused about questions that are being asked or anything like that. But generally, so not so much the specifics yet, but any like general questions or comments or anything? Yeah.
Jumping on too much, but what does like the timeline look like? Like when would you start applying with?
Yeah, great. That's a great question. So February is usually the magic time. So I think a lot of the REUs this year do have due dates in February. February 15th usually, February 31st, sort of those two are the magic days. So if you are interested, get started on finding letters of reference, get started in finding references. Usually the rule of thumb of that is you should allow 4 weeks for someone to write you a letter of reference. Obviously, the more time you give, the better. If it's a professor who you really know and who you're really friendly with, you can sometimes get away with 2 weeks, but that's kind of pushing it. And I know some people will do a week, but again, that's a very rare exception. But yeah, so usually it's February. So you start looking for references about now. Submit those applications middle of February, end of February, and then you should hear back beginning of March about the programs. Okay, one other quick thing I want to point out is you will notice that if you paid any attention to the flyer that we sent out, all the panelists that we have here are from non-Northeastern affiliated REU programs. There is a Northeastern REU program as well. It is, and for those of you who are wondering, it is happening this year. However, it is not, falls under, the technical explanation is it falls under a different grant than normal REU programs. And so it's not going to appear in that list of NSF funded REUs. And so if you are all interested in the Northeastern REU specifically, which is the exact same, right? It's paid $4,000 stipend. It's either on campus or virtual. You're doing some sort of research project working with a professor or faculty member. So all of those things are exactly the same. All those things are exactly the same. It's sort of a different application process. If you are all interested or have any questions, there are a couple of people here, including myself, who have done the Northeastern REU. So definitely when we have our Q&A session a little bit later this evening, feel free to ask about that or feel free to send me a message at any point. But I just wanted to announce that that's kind of the first official announcement that this REU is happening. So I'm kind of happy that we are able to do that this evening. But yeah, Kiana, I noticed you said you have a question. Feel free to put it in chat or unmute yourself. Great question. So the question was from Zoom was, is there any difference between an internship and an REU? And yes, there is. Internships usually are, well, it depends, but internships are usually industry focused, whereas REUs is usually happening over the summer where you do have some research component, although I'm sure there are spots that cross over. As to whether one's more preferred than the other, it really depends on what you're looking for. I think if anyone has any sort of things to add, but I think probably internships are good if you're looking at specifically like master's programs, whereas REUs more so if you're looking at PhD programs. But I don't know, any thoughts from our panelists about that?
I did a co-op and internship at an REU, so
Okay.
later on I could see.
Okay, it sounds good.
Yeah.
Sounds good. So yeah, so definitely, if we don't hit your question, Kiana, at the end, let us know. So with that, we are going to jump into the actual panel portion of the panel. But yeah, so I would really like to welcome our four panelists, Josue, Nick, Max, and Rose, as well as our the person who's moderating tonight, Sam. So if we just want to give them a round of applause. Yeah, I'll stop talking now. Yeah, all you.
So now it's my turn to talk. And then I'm going to just start off by asking you all to speak a little bit about your REUs. Where were they and what was the topic? Rose, if you'd like to go first.
Sure. Hi everyone, I'm Rose. I guess just to give you a little bit of context to who I am, I'm a first year PhD student in Corey College, but I did my bachelor's here at Northeastern. So this is like my 5th year in the area. I was a math major and I came in as a physics major for my first 2 years, switched to math, and then somehow made my way to computer science. So I can talk to that as well. Anyway, so I did a math REU at UConn, and we were doing algebraic combinatorics, which I think combinatorics is a really great field of math. Especially like, I just feel like it's a very accessible path. So if you don't know what to do, like, I don't know, you can always apply to combinatorics, I guess. And so I could talk about this more later, but give other people a chance. I kind of panic applied the last week of February. I was like, what is an REU? Oh, I guess I should do one. And it all worked out great. So here's some hope for you. But anyway, so I kind of landed where I am now kind of by chance, but it was a great experience. And I highly recommend applying even if you don't have a game plan yet for what you want to do with the next few years of your life. Yeah.
Very reassuring.
Yeah, so I'm Max. I am a 4th year math and CS major in Corey College. I also study some physics. My REU was virtual in summer 2020, hosted by ICERM, which is the Institute for Computational, Experimental, and Research Mathematics, I think. And so it's really oriented towards computational areas of mathematics, and in my case, towards machine learning and numerical algorithms. So my specific topic was a type of algorithm called graph spectral clustering, where you cluster some data and group data points into similar categories using a graph derived from data. That was our research topic.
Hi everyone, my name is Nick Bitterini. I'm a 3rd year math major. I'm looking at a physics minor. In the summer 2020, I participated in a polymath REU. This was an online REU held at institutions all across the country. There was a project for everyone, covered a broad range of topics. My REU specifically was on functional analysis and studying mapping properties of something called a Toeplitz operator on different spaces and trying to verify results on one space and see if they work in another space. So it was very, very eye-opening. I learned a whole lot, and yeah.
Hi everyone, my name is Josue. I'm a 2nd year math major here at Northeastern. Over the summer, I had the opportunity to do conduct research at Carnegie Mellon University program called SWAMI. It stands for Summer Undergraduate Applied Mathematics Institute. The program was mostly virtual. I think we did 8 weeks over Zoom, but then we had the opportunity to go last week in person, which was great. I really liked Pittsburgh. My topic was research was on graph theory. In particular, we were learning a little bit about very cool graphs called hypercubes. And we were interested in the edge disjoint decomposition of the hypercubes into like path and cycle graphs. In the end, we were working, because there's this kind of like famous conjecture by a guy named Joshua Erde. He stated a couple of necessary conditions for when we can decompose a hypercube into path graphs. And we were working hard on proving that conjecture. In the end, we couldn't, but it was still a fun time, and I did learn a lot about graph theory.
So in case some of that didn't make sense to anyone here, you're definitely not alone. So I guess before we get into questions about how the actual REU looked like on a day-to-day, I guess I'm going to kind of blindside you guys and ask you, what's the most, if you had to explain your research to someone like a lay person in just a sentence or two, what would you say? So I guess, do we have anyone brave enough to go first?
I'll go first.
All right, we have a taker.
So I mentioned graph spectral clustering. And the big idea of this method to find similar groups of data is to write down a graph whose edges represent individual similarities between data points. So if I have like some data point that represents maybe universities in the United States, you can have a graph that represents geographic positions, and then it kind of looks like an outline of the United States with connections between major cities, a little spider web on top of Boston. And now the way to find clusters within this graph is actually to simulate heat diffusion. Making that connection is the big part of our research. The reason you simulate heat diffusion is because if you imagine the graph with small local clusters, heat, maybe that's like, let's say we imagine Northeastern is very hot, great university. It diffuses to the nearby universities, and the ones that it diffuses fastest to belong to the same cluster. And so by analyzing a PDE on a graph derived from the data, specifically with a kind of spectral analysis, which is coming from linear algebra, we researched an automatic way to extract these clusters. A little manuscript about it.
Very long sentence, but we'll take it.
Can I give a long one sentence?
No, of course, everyone, yeah. You take as much time as you need, yeah,
All
don't
right.
worry.
Ready everyone? We're gonna go with a drawing. Okay, let me know if you can see this. This is a polygon. And what you can do with a polygon is you can triangulate a polygon, which means you can add some lines on the interior and break it up into triangles. And so I could have done it like this, or I could have done it like that. And what you'll notice between these two different types of triangulations, this one has a negative slope and this one has a positive slope. So we say the one with the positive slope is bigger, is of a higher ordering than the one with the negative slope. But what happens when your shape has n endpoints? Now you have a bunch of different ways you could triangulate it, but how do you compare it? And how can you predict like the different orderings of those shapes? And so we studied a particular kind of polygon, which had equal amounts of points up here and down here. And we looked at all the different ways you could triangulate it for all values of n, and tried to understand the partial ordering of these shapes. So that was my project. Yeah. But actually we did 2 projects. That was one of them. But that one I was like I did the most work on out of my collaborators.
Very cool. Nick and Josue, which one of you is next?
All right, I wish mine were as easy to explain in the picture. So functional analysis, specifically we're looking at just to kind of brief over your functional analysis. Functional analysis is you have your idea of a function, right? That can take things from a domain X to Y, right? And you have all kinds of impositions on functions, just make them functions. Functionals are kind of a more generalized form of functions. And so you have a lot more freedom as to what you can define them as. Because now you're not really talking, sometimes you might not be talking about mapping elements, you might talk about mapping functions in one space to functions in another space. And it's very, very abstract, very, very theoretical. There's a lot of applications with functional analysis, a lot of applications to solving differential equations. There's applications to calculus, to complex analysis, but it's not very accessible. You would have to have at least a very solid background in calc before you can start looking at the stuff you have to read for this. But I'm sorry, basically just to kind of put the objective of my research into plain, kind of easy to understand terms. Different domains in the complex plane, you have like A plus BI, right? In the complex plane, you can cut out subsets of that, and you can consider functions on those subsets, like you can consider functions on the unit disk, you can consider functions on like a strip, you can consider functions on the whole of C. And we were interested in looking at the properties of functions on a subset of the complex plane cross itself, called the Hardtop Triangle. It's a subset of the C cross C that has certain restrictions on exponents. And what we were doing is we were comparing the results that were published in a paper on a certain projection from the whole C cross C to the disk, and the disk being just kind of unit one, and then your functions on that disk. And so we were studying a projection that operates, this projection is a functional, it operates on functions on the whole of C cross C onto the functions on the disk. And you're trying to understand, okay, if we map this function to this function, what can we say about the target function based on properties that we know about our functional? And so we were looking at this projection called the Toeplitz operator, which basically it's kind of like an inclusion map with modification. So if you have F on your whole space, just the kind of the inclusion map would just be okay. Now just consider F just on the domain, and that's basically your Bergman projection. And the Toeplitz operator is just the Bergman projection where you just multiply your function by another function first, and then that gives you the Toeplitz operator of a certain symbol. And so the symbol really characterizes the properties of a certain Toeplitz operator. And so we were trying to understand, based on certain conditions on the symbol, what kind of mapping properties can we get from C cross C to the disk, and now compare it to, let's look at Toeplitz operators from C cross C to this new domain called the Hardtop Triangle and see what differs about these. It's it's kind of out there. The applications are, I don't really know what the applications are. It's very, very abstract, but just with how much math I had to go through to learn that, all the reading I had to do, gave me just a whole new appreciation of just the work that goes into solving differential equations, the work that goes into just performing basic calculus. So yeah, so just all in all, we were trying just to compare results on one domain to another domain.
Definitely, it would be tough to explain with a picture. Yeah, but thank you, but good explanation.
I tried my best.
The time has come, that's why.
Yeah. So, like I said, I mentioned this really cool graphs called hypercubes. They're basically like an n-dimensional analog of like the cube or like a square that we know. I'll try to keep mine into one long, simple sentence. Actually, in graph theory, there's this, it's very common to find problems that are super easy to explain, but then if you try to prove them, they actually turn out to be extremely hard to prove. So I mentioned also edge disjoint decomposition. So if we consider, so basically a hypercube, the notation we use is Q sub n, where n is the number like the dimension, for example. So if we consider a square, that would be Q sub 2. And there is this property of hypercubes that say that a hypercube has 2 to the n vertices. So like I said, a Q2 would be 4 vertices, right? That's just a square that we know. An edge disjoint decomposition of a square, for instance, would be just take the 2 corners, right? If you have a square, you can take like the 2 different corners like this. These are 2 different pieces, 2 different graphs, and that is an edge disjoint decomposition of a Q2 or square, whatever you want to call it. Now we can move to a Q3, right? Now we have 8 vertices, and that's a cube that we all know in 3 dimensions. Now you can probably imagine that, okay, you can still find edge disjoint decompositions into paths. You just have to like play around, right? You can use like different, if you draw like a cube on a piece of paper and then you keep drawing, you can have like different colors, draw different paths, and then you can, if you're clever enough, you'll find a bunch of different decompositions. But now you might be wondering, we're obviously not interested in low dimensions, Q2, Q3, even Q4. But let's say Q5. Actually, the last one that we could decompose during our research was Q30. Now you might wonder, how can we decompose a graph that has 2 to the 30 vertices? Well, that was what our research was on, pretty much. And the idea was to think of super high dimensional hypercubes and look at very specific slices of them. And if you understand a slice of a hypercube, and then if we know how to find a particular decomposition into path or cycle graphs of that slice, then when we look at the total picture, we can basically, given some properties, we can collect all those decompositions of the slices, and that in its totality will be a decomposition of the entire hypercube. I also mentioned this conjecture, and it stated some necessary conditions for a decomposition into path, decomposition of a hypercubes into paths. And for all that we know, that could be false. We could have like a Q70, and it could be a counterexample, and then our conjecture is false. But yeah, and now you also might be wondering, like, why on earth would he want to decompose a cube in 70 dimensions, for instance? Well, it turns out that there are some applications into like computer networks. As you may know, CS is deeply related to, graph theory is deeply related to some applications in CS. From thinking of maybe if you have maybe n people, and then if you look at the friends, like if you consider like all the friends that all the n people have, and then if you look, all the mutual friends and all that stuff, we can create all this kind of like webs, and somehow hypercubes have applications into those kind of networks. But yeah, that's basically what I did.
Fantastic. So for the next question, and hopefully this will be shorter across the board, is what were the kind of day-to-day, like what did the work look like for the REU? Did you have like a supervisor or a boss? Did you work with colleagues? Like what was the level of experience of people that you worked with? And I guess I'm going to start off by asking who here did their REU online? Because
so mine was 8 weeks online, and then I had a 1 week in person. Does that count online?
yeah, so okay, everyone did their stuff here online, so that's good because presumably in the future REUs might be online for a while.
So just to quickly, most of the REUs are planning to be back in person based on what's listed currently. However, obviously things might change, so just pay attention to the actual individual sites if you're interested.
So you had 1 week in person, I guess. So then if we're going to talk about in-person stuff, what was going on, I guess, for your REU? And then maybe was the in-person stuff a little bit different from the online? Like,
yeah, so in person was great. Besides getting to know the city, of course, we met with, there were 2 groups of 3 students working on graph theory projects. There were other groups working on like some finance stuff. But at least for the graph theory, after 8 weeks, we already had a rough draft over in LaTeX of like our main results and like, what do we have so far. So the last week was basically to create a formal document stating exactly, like taking everything that we had from the rough draft and putting it in a formal form so that we can write down a paper and publish it, hopefully. So I'm not going to lie, the last week was mostly, you know, like, okay, not mostly, we did work, but after 8 weeks, after 8 weeks meeting over Zoom, right? We were working anywhere from 5 to 7 hours a day. You know, we needed some rest. So that last week, we actually spent quite some time just going out and knowing, you know, like various places of the city. But like I said, my in-person experience was basically talking to to the colleagues, brushing up some of our results. And we also created a poster which we later presented to the faculty. But yeah.
Yeah, so that's really cool that you got to meet everyone in person. Had a great time. So hopefully you guys also had really great times. Which I'll now give you a chance to talk about just after reminding you guys. For the sake of time, it's about 6 o'clock right now. So we're gonna try to keep stuff to 2 minutes. So I'll let you guys know if you're starting to get. Yeah, Nick next or Rose, would you like to go next?
I go. I would really agree with Joshua that the REU is a super fun social experience, but my day-to-day work was really involving a 1-hour meeting every day with a graduate student who was assigned to supervise our project. And as well, a 1-hour meeting once a week with one of the 3 faculty members who were the hosts of REU. And we spent the first week of the program choosing topics. And then we spent about 10 weeks, I believe, working with this day-to-day schedule where we can set our own time outside of meetings. And like Joshua at the end,
So for my REU, we had a weekly meeting with the project supervisors, professors, and the grad students. They basically talked about what problems that they're interested in that week. And then we kind of delegated the work, just like assigning like one problem to a couple of students. And then throughout the week, you kind of work on that on your own or with the student you're working with. And after that, the next week, you'd go back and you report your progress. At the weekly meeting, there was a lot more communication than just the weekly meeting. It's not like we only spoke to our advisor once a week. But I guess for the first week, it was a lot of just, here's the reference text, go read. And then after that, they introduced the problem after like a week or so. And then after that, it was really just kind of either working by yourself, just kind of pouring over the theorems and past work, and then collaborating with your group mates to try and verify results. So it was pretty free form. Time wasn't really structured. You're at home or working from your desk, go do whatever. Yeah, it was a lot of freedom. Basically, you get out from it what you put into it.
Yeah. I had a very similar experience with them. I mean, when you go to an REU, lots of times they give you like kind of a pre-packaged problem to work on that fits within the scope of the summer. And that's one of the really nice things about it, is kind of, it's a different kind of reality than being in the real world, I guess. But I, in particular, was working on these combinatorics problems, which tied to like permutations. And so I spent the first half of the summer like programming, coming up with algorithms to like check certain conjectures about permutations, just to like, because the software we were using like didn't have what we needed, and we needed, it was nice to like actually see if any of the conjectures were false before trying to go and prove it. So that was really fun. And then kind of the second half, I got more interested in kind of more of that shape problem. That's a very like broad overview of it, but I figured out this cool theorem, and so I spent a lot of the REU kind of like trying to write that down and like explore it more. And I was working with 3 other students one from Swarthmore, MIT, and WNUC, I think it's called. And it was cool because we were on Zoom, but we like found ways to like we'd spend an hour every day playing like Drawful, is that what it's called? Or like whatever the Jackbox games. Like we were just kind of goofing off, not gonna lie. But it was great.
Awesome. So this is another question that I think is really important for people looking to apply to REUs. What was an important skill that you either was really good on your application and you felt was important to your success at the REU, or something that you felt you had to learn while you were on the job? I guess just another way of phrasing that is, what's an important skill for having a good time on an REU?
Yes, I can answer that one. So something really important I learned when I started REU was I had experience with complex analysis from taking coursework and stuff before the research, but functional analysis is just so well developed and so out there that it's been built so much that all of the theorems have so many prerequisites and so much prior knowledge you have to know that you can't learn that all in 1 week. So when we were given reference text and stuff, I found that really the strategy when you're going into a new topic or like anything sufficiently complex, you're going to be working at the forefront of that, but you really can't spend every second learning everything that happened before. It would definitely be like kind of a less is more approach, really kind of focus on what facts, what theorems are the most important, kind of understand the statements of them, but don't necessarily you don't have to necessarily understand every proof or everything that goes into your work, because if you spend too much time on the details, you're not going to have enough time to start actually applying it here. And so that's something that I struggled with for like the first week. I was like, oh yeah, I've been reading proofs and theorems like all day. I'm like, when am I going to start doing research? My head hurts. And so it's just kind of like taking that step back and just identifying what's the most important things you have to know for your research, and really focusing on understanding those, looking at examples where those apply, and then use it in your research.
Cool. Yeah. Anyone else? Yeah.
I can say something. So, okay, it's hard to like tell you like skills you need or skills you'll learn from the REU because you guys haven't done an REU yet. So I guess I'll talk about like the intersection between skills that are important to an REU and skills that are important to your life right now. And so I guess there's two. One is just having grit. Like sometimes things are hard and you don't want to focus and you'd rather tune out, but like actively engaging with the material you're looking at and even just staring at the same thing over and over again, eventually you kind of carve out that nugget that you find interesting or you find that ledge to hold on to. But the other thing is like, I learned really good communication skills the summer I was doing the REU. Maybe part of it was because it was on Zoom, but like talking about math is hard, and being able to express what you're thinking in a way that's efficient so that other people can like grab on and say, oh, I got it. Like, I understand what you're saying. Like, here's how I go from that. Or likewise, somebody's explaining math to you, and if you don't even know what you don't know, like, just listening and saying like, okay, what are the appropriate questions I need to ask to, again, find that like foothold? I would say like, not only are they important for the REU, but if you can like key into those now as you are a student in, hour 40-minute classes that, if you blink and you miss something, you're lost for the rest of the way. Like, I think these are good skills. Yeah.
I totally agree with that. In fact, it was the skill I planned to mention would be communication, and then you said everything else.
I'm sorry.
No. Well said.
Thank you.
Yeah. Josue, anything to add? Just brief thumbs up.
I would say most important, you asked the most important skill you need or you learn?
Either. They're both good
Okay.
questions.
I would say you have to be very patient, at least for my experience. There were weeks where, okay, maybe not weeks, but there were days in where we did basically no progress. And that meant that, okay, I did say that we were on Zoom for like 5 hours, but that doesn't mean that we were like working or like actually like making progress for 5 hours straight. Because if we did that for 8 weeks, then I mean, we'd probably do a lot more than we did. But what I mean is that there'll be a lot of time that'll, maybe you can think that it's like dead time or like time that you're not doing anything. And it's very easy to fall into this trap of, oh, do I really know what I'm doing? Why am I not making any progress? You know, I suck or whatever. So I think that you have to, and yeah, I think, you know, perseverance, and you also have to be very patient. You know, the results will come. I plan to talk about my favorite aspect and also my least favorite aspect. And they're all very tied to, you know, having my least favorite aspect is the dead time. I'm not doing anything, not making any progress. But at the same time, my favorite times were those in where we had like, oh, wait a second, we can apply this idea, or we can use this that we haven't tried, and then we get something. So yeah, just be patient. That's what I would say.
Okay, now I'll say something, which is that I also agree with you. Patience is totally key, but I want to bring some hope into the conversation, specifically just to say that sometimes after all your hard work and patience, the cool thing happens. Not just sometimes, almost all of the time. Research has been really amazing, at least for me specifically, to find topics that I'm interested in, and to dive deep and, you know, create the glowing lizards, as the scientists say, but in math world.
Never heard that one.
Yeah, it's like what you do when you're not writing grant applications. And so I would encourage you to consider the REU as an opportunity to build a specific interest. And while that will be challenging, it's totally worth it. And it's amazing to reach the end point. So something to consider.
Awesome. So you guys talked a little bit about what was difficult on your REU. Was there a part that was hardest or your least favorite on your REU? And then, yeah. So who has anything that immediately springs to mind for their least favorite thing they dealt with on the REU? Well, that's a good sign.
Yeah.
Mine's like very REU specific, and I don't know if it'll add value to the conversation. Because I just think like my REU is kind of weird in some ways.
Sometimes it's hard to collaborate, right? When you meet new people and you're expected to produce something in a short amount of time, especially if that all happens over Zoom, that can be challenging. I have some of the same problems, but the REU was a great experience. I mean, every part of it, I think, on the whole, is a good thing to be part of.
Oh, I know. Curse of knowledge. Do you guys know what the curse of knowledge is? The curse of knowledge is this idea that like I have a lot of knowledge about my niche that I take for granted. And so when I'm talking to you about my niche, I'm making these assumptions that you don't have, and you guys are totally lost. And so every week we had to give talks where we would build off of the previous talks. And there were like other groups too, so they would talk about work that I wasn't working on. And every week they were building off of the thing they described in the previous week, but I lost them at week 1. So it was just like an hour and a half of me not understanding anything. And yeah, don't give crappy talks because everybody suffers. Yeah.
I've been in that position before, both as the lecturer and as the listener. So that's definitely good advice. Josue or Nick?
Yeah, I guess I just have to agree with that. Just sometimes people are going to be talking about things and you have absolutely like no clue what they're talking about. Like there's some times where I'm just listening to other students in the meeting just talking about, oh yeah, we proved this theorem. Yeah, like obviously this implies. I'm just like, what? because I only knew the stuff that really pertained to my problem. Just exactly like you said. Just it's an uncomfortable feeling to like not know what you're talking about. Oh, if only I'd reviewed the material better. Just like stop that. You're in the REU. You deserve to be there. You're working on the project. So it's okay to not know. That's why you're researching.
Yeah, I don't have that much to add. I definitely agree with Rose. So we did. I mentioned there were two groups of graph theory, and every week we had to give a brief 30 to 1 hour talk to the other group, explaining like our progress of the week. One thing I learned was to start from the very basics. Like even if you think that something is trivial or remember that you've been working with those definitions or whatever for weeks and weeks. The other team hasn't had that much time working with those, or maybe they haven't worked with them at all. So it's very important to like obviously know your audience and yeah, give a good talk that starts from the bare minimum.
So I guess then to follow that question up, what was your favorite part of REU? We all knew that this was coming, so if anyone has it. Yeah, so, well, Max is.
Because I was just talking about what like glowing was making. So I will tell you about a very cool thing we did during our review. We also would goof off for hours a day. But our game is code names. If any of you guys know this game, you kind of have a grid of words, and then the challenge is for one of the players to say a word that relates to some other words that you have to guess in the code name. So this is a clustering problem. And we used graph spectral clustering to build an automated code names robot, which it was kind of bad at the game, but it wasn't awful. And the fact that the algorithm that we designed just by kind of writing down some ideas we had worked with during our REU, the fact that it worked was super cool.
Yeah, I guess my favorite part was kind of after like the whole reading phase when you start working on your problem, just like the moment that like all like you feel like you're lost, is all this new information that you just learned, you're trying to apply it. And just that moment that you get when you figure something out that's new. That's just like, hey, this might be useful in a problem. And like figuring out, oh, here's some little lemma, here's some theorem that might work out, and then you go improve it. And then you go, holy crap, I'm probably the first person that like ever did this. And just like just having that feeling is just, it's accomplishing something, no matter how small, no matter what little nugget you get, it's just so gratifying. It just makes the whole experience worth it. So yeah, I guess like when I got my first tiny result, that was like really the best part. So
I have a favorite part. So, okay, just some context. So my boyfriend is a theoretical computer scientist, which is fancy words for a mathematician. And so I like live with him, right? And I've never seen him write math down on paper. And I'm like, when he does these things, like he goes on walks or he plays basketball, I'm like, what are you doing? He's like, I'm thinking about math. I'm like, what do you mean you're thinking about math and not writing anything down? He's like, dude, you gotta try it. And I'm like, okay. So this is like a conversation we had during our REU. So one time I was like, I'm just gonna go and think about math, I guess. And I like went on a walk. I just paced like back and forth on the Esplanade. And an hour into that, I came up with like a really cool idea. I was like, damn, everybody should go on a math walk. It's, I think, realizing that you can like, I don't know. I think I had the realization not all of your like creative ideas will happen at like random times, and also like being able to like do something like that was like very cool. And so that was like one of my favorite parts. And also that was the nice thing about the REU is like you don't have to be somewhere at a specific time all the time. Like you're kind of just chilling in a school and you can do whatever. And that was a cool discovery for me. Yeah.
Walking or sleeping on a problem or something is definitely a big help. Unfortunately for me, I usually make all my discoveries right as I'm falling asleep. So that's okay, now I got to get out of bed, right? Yeah. So Josue, your thoughts?
Yeah. So my favorite parts were the moments right after we were stuck for like maybe a couple of days, and somehow we came up with a new idea. We can apply this there and there, and oftentimes, more often than not, I want to say we made some progress. So that I have to second Nick here, that those moments are really gratifying. Like you've been stuck for so long, you have nowhere to go. You think that there is no solution to your problem, and then out of nowhere, you get new ideas and you apply them and they work.
Awesome. Yeah, those are all great answers. So the last question before we move into the Q&A section will just be short. What advice do you have for someone who's maybe interested in REU and thinking about applying? So application tips, strategies, stuff like that, stuff you wished you knew. Go wild. Anyone have any thoughts at the start?
We'll get like apply for your, ask you for your rec letters like now, as in like while you're sitting here. Because you want to give them as much advance notice as possible. I know I had an issue where like I was really running up on a deadline and like I got my rec letter like just in time so I could submit it, and I really don't want to do that again. So I guess just like it goes without saying, just like kind of be courteous to your recommenders and just really give them good notice. In terms of just like applying is free. So you can cast a wide net. You don't have to really pay an application fee for a lot of REUs. I haven't heard of one where there is an application fee. But yeah, put yourself out there. If it's something that you're even like moderately interested in, just like say so in your personal statement, hey, I'm curious about this. I read about this, I think this is interesting. Just to kind of, and just aiming, yeah, you'd be interested in, because all these programs are pretty competitive. So if you cast a wide net and you would be not even like slightly interested in any of the things you applied for, then that's good. So you really just want to like maximize your chances of getting in. So just apply to anything that kind of seems interesting. That's not to say that you should send like a copy paste personal statement to everyone. You definitely want to take some time to tailor it each individual program, but definitely don't limit yourself with only applying to like one or two, just because you're gonna need the volume. Yeah.
Sounds good. You heard them, folks. Fire up those phones. We won't blame you right now. Yeah. Yeah. So thanks for this way.
I think my advice would be not to overthink your application. It's not a commitment to go to grad school. It's not a commitment to pick a career path. I really would think of it like a kind of tougher version of a cool summer vacation, where you really do take an excursion and learn something new. So I encourage you to put yourself out there and ignore your doubt, if you have any, that it might not be the right thing to do, because the whole point of the REU is that it's a way to try research.
Yeah, I kind of want to add to that idea. So somebody asked earlier, like, what's the difference between an internship and an REU? And if I had to like generalize this as best as possible, interns are companies are hiring interns because the company needs something done and they need cheap labor to do it. Not to say that an internship is bad, but an REU is designed for you. Like, it's kind of like when you're in academia, there's like this culture of like helping other people. Like, it's like you feel like you have an obligation to help your community. And it's like the same thing. It's like, it's not about, okay, what can you do to benefit this school? It's like, no, like these people, like they want to help you. And so that's the difference. In terms of applying, like Nick said, I mean, you're just speaking from a probability side, you should apply to as many as you can possibly apply to, because that just increases your expected number of applications you get. But obviously, you know, within, that doesn't mean like sacrifice everything in your life to apply. Like, apply within, you know, the means of what your schedule can allow for, but don't not apply because you don't think you're going to get in or something like that. Like, you should always shoot for the stars, even if the probability is low, because it's non-zero. And then in terms of the application, this is like, there are some parts of it that like, it's, we've gone through and we know, like, okay, you have a personal statement, you have like some other short answers you have to do. And it's another one of these game things where like, it does help to know like how to play the game a little bit. So I guess like you could reach out to me or probably anybody on the panel if you have like specific advice to that. It's good to like check in with somebody instead of just feeling like overwhelmed and like, what are they looking for? And then the other thing is just like click on all the applications and see what they require and see like how many of the applications are similar. Like, okay, some of them might ask the exact same question, but worded slightly different. And you can do the thing Nick was talking about where you can just tailor it slightly. And so if you have that at the start, that's going to help you for the next few weeks to figure out like what is the work you need to do.
Yeah, like I would advise like you really go out your way to like write an awesome personal statement for like one of the programs you really want to do, and then use that personal statement as a template to base your other ones off, not necessarily copy pasting or like filling in the blanks, like move a couple things around or like say, oh, I provide this piece of information out of this one. But once you do one, you're halfway there for the rest of them.
That's right.
My biggest tip of advice would probably be not sleep on the deadlines. So last year, I definitely learned about REUs a little bit. I think it was probably the first weeks of February. That's already a little late to start applying, I'd say. Plus that, I did the mistake of sleeping on the deadlines, which meant that in the end, there were a couple of programs where I was really interested in, but it was past the deadline, and for most of them, they have no exceptions. So like all of the panelists have said, if you are interested in applying to any REU, I would definitely start looking for a letter of recommendation today or to whatever, coming Monday, and really start looking at the application.
So, all right, now you've all been very patient, and as your reward, we will have a Q&A session and then pizza later. Most of the pizza, but the Q&A session is good now. So if anyone on Zoom has any questions, I will come over here and force myself.
I actually, Chad, I'm going to interject while you do that and say that you may be wondering what makes a good personal statement. And I'll tell you that we have an entire office called the Office of Undergraduate Research and Fellowships at Northeastern, which offers personal statement writing workshops. If you reach out to them early enough, they will help you write a personal statement and give you reviews. They're super nice. And so I really recommend reaching out to their office to find REU opportunities, to find assistance in applications, and to find other research opportunities, because it's what they're designing. That's PERF, that's Undergraduate Research and Fellowships.
I'm just going to second that. They're a great resource. The director of the program, Dr. Iacono, is amazing. So yes, use them.
Sorry, what is it called?
Undergraduate Research and Fellowships.
Okay.
So you can Google Northeastern PERF, and their website has awards, opportunities, and these workshops. Right? Yeah. It's a whole office dedicated to undergraduate research, and they offer funding. You can apply for awards. They helped me fund a global co-op recently for a research program. It's absolutely like your first point of contact if you're interested in undergraduate research.
Awesome. So that's really good to know. So thank you all. If anyone here has any questions, I see that we already have 2 takers. If there's anyone on Zoom, there's one person. There's one person on Zoom. So if you on Zoom, I'm speaking to you now out there. If you have any questions, then shoot, and I'll read it. I saw your hand go up first. So go and ask a question. So.
Yeah, this is a kind of general, as I'm just in my 2nd semester at Northeastern, but what have all of y'all favorite classes have been here when it comes to math, but also maybe CS and physics, like the most insightful ones, and maybe specifically classes where you took the stuff you learned and maybe extended that into the work you're doing in REU or just research that you've done or yeah.
I guess for me would be, I believe the course number is Math 4545, partial differential equations. I think it's taught by Dr. Jekyll usually. It basically goes into how differential equations with more than one variable are solved, and it's applications like immediate to physics is solving the wave equation, solving the heat equation. And you use a lot of tools from calculus and linear algebra, surprisingly, to assemble your solutions. A lot of cases, your solutions aren't really able to be written in a nice closed form, like, oh yeah, like x equals x prime, the solution's gonna be x, yeah, no duh. But what if you have a really annoying system like second order differential equations? What's really, really cool is that your solution is written as like, it's like a sum over a basis of functions. And I just found that so absolutely fascinating. And so guess part of that's what inspired me to apply to the analysis RU that I was doing, really involved with calculus and those applications. The RU really gave me a better appreciation of what I learned in that class. So super, super cool class. Definitely, if you've got a free elective and you want to know more about like what goes into math and like, physics and stuff, definitely go look at that. Not 45.
It only requires DPQ 2941, so.
Yeah, I just finished it with Professor George. Really fun class, lots of cool theory hiding there. And also the book has one section where it's just like, oh, here's like 20 other differential equations that you now know how to solve. And it has applications for like computational biology, like computer science, a whole bunch of crazy stuff. So really great class for engineers, anyone interested in applied sciences, and then yeah, functional analysis stuff. So.
So the favorite class I've taken so far is topology, which in simple terms, for at least for the basic introductory level that I study it deals with classifying surfaces or like objects up to some type of equivalence. I know that sounds kind of hard, but for example, maybe you've heard of like a meme that for topologists or for mathematicians that like a cup of coffee is the same as like a donut, for instance. But okay, and kind of like as a side note, you reminded me of actually something that I don't think either of us mentioned, is that for a lot of these REUs, you don't actually need, for example, I did an REU in graph theory, right? But I've never taken a graph theory class in my life. So for most of these, you don't actually have to take the classes. There are no, and there might be some exceptions, right? But there is no such a thing of like a formal prerequisite, for instance. And like we've said so far, the main goal I'd say is for you to learn about the topic. Of course, it is very helpful if you already have some previous knowledge, but you don't necessarily need a class in that particular subject in order to do an REU.
I like analysis too, which was very useful foundations for my research. And I encourage you to talk to professors if you're doing research about what courses are foundations for their work. That's all.
All right, take what I say with a grain of salt, but if you can dip your hand into some CS classes, like if you want to hit the Python data science class, and if you want to hit an algorithms class, definitely algorithms, like just to like do math, but like wear a CS hat secretly, like I would definitely do it. It's like the way to kind of like BCS without taking fundies. And also it's like good to know programming. Also, I really enjoyed stochastic processes. It was like one of my elective classes, but like that one is like the class that like still remains like pretty relevant to me. Yeah.
It's just like I want to add one more thing. It's not really a math class, it's a philosophy course, but taking it felt like a math class was ethics and evolutionary games. Professor Rory Smith teaches that. I believe the course number is Phil 201 to 2001. It's about game theory and how it applies to like real life situations. And you really take a surprisingly like mathematical approach to it. Like, oh, given a game, like what's the optimal strategy? Like what is rationality? What does it mean to do things in your best interest? It's a surprisingly rigorous course. It's a fascinating course, and it's very, very accessible. You really only need to know algebra, just like basic high school algebra, maybe a little bit of algebra. Fascinating course. I definitely recommend it.
If you'll permit me to answer the question briefly, I really like number theory 1. Especially the algebraic stuff towards the end. Definitely felt like you're going a level lower on the iceberg of math. And if you pursue algebra and stuff later on, then you see really cool, really interesting objects like the Gaussian integers or cyclotomic polynomials crop up in the most interesting places. I think also group theory, or in my case, algebra 1, is really interesting and really profound, actually. So it's a really cool class. Maybe you want to answer.
I'm thinking for the sake of time, there are plenty of good classes. We could probably have a 45-minute conversation
So
about
that's
this.
enough.
So
Yeah.
but all of those ones recommended are great start. Now it's your turn.
My question is about like applying for REUs. So like I'm planning on doing summer one or like the first set of summer classes. And then obviously it's like there's a set period of time and then the next school year starts. So is that still like what is the timeline? Would I not be able to do an REU if I had summer classes? Or I was just thinking about that like logistically.
Most REUs run in July in a way that is logistically really bad for split summers. So some alternative options that you have are to find rare REU programs in the second half of the summer, or you can essentially self-develop an REU if you find a professor who's willing to work with you. And this is maybe less known of a fact, but any professor who receives funding from the NSF can very easily request REU funding to pay an undergraduate to work with them during the summer. So I encourage you either to find rare REUs with summer due dates or to self-develop an REU.
I guess just kind of add to that, last summer, I also applied to REUs. However, I was doing a fall co-op, so that co-op started June, July. So like the co-op started like right a couple days before most REUs ended. So there was a little bit of overlap, and that made it difficult for me to be able to accept REUs because this is kind of the way they work, because the stipend you're like required to stay there the whole time. And because I was on co-op, because there was that conflict, like there were a lot that I couldn't apply to. So basically that, like, yeah, if you're gonna be doing co-op or if you're gonna be doing something else like summer 2 classes, definitely check those dates. Your options are going to be limited, but I would not discourage you from applying if you need to make.
So are most REUs like May through June, or when is like the typical one?
I mean, yeah, that sounds about right. May, June, some July.
I can kind of give the answer to this as well. So it really depends on the program. Like I said, it's usually 8 to 10 weeks. So, about 2 months. Again, there is that sort of weird issue where a lot of them sort of maybe start June 1st and go into July 31st or things like that. So really not conducive, as Max said, to Northeastern summer 1, summer 2 schedule. However, definitely all the dates are posted, on every single application that you're looking at. So definitely pay attention to that. One thing I will say too is obviously it was honestly easier the past couple of years because they were virtual. And so you didn't really have to worry about like being in 2 places at once. So yes, Nick was absolutely right in the sense of, once you're doing an REU, you're supposed to be doing that. But like, if you ended an REU on the Friday and then started your co-op on the Monday, that's not necessarily as big of a deal as if you had to travel across the country. However, there are a couple of REUs that do fall just May, June, as well as just July, August. The one that I'll mention again is the Northeastern one that strictly falls during summer 1, but there is an option to do an REU equivalent type thing, summer 2 occasionally. So definitely, that is an option. But yeah, you really have to sort of pick and choose wisely.
Can I add to this?
Yeah.
So, okay, I just want to give a shout out to Northeastern's REU. It's a great REU. I didn't do it because of the scheduling conflict, but like if you decide, okay, maybe I could take classes summer 2 because I want to take classes, not because it's a specific class that's running summer 1, then I would highly recommend doing Northeastern's REU. The other thing is, even if you think you're doing classes summer 1, you should still, I personally think you should still apply to REUs that you don't even think you'll be available for, because things change. Like, okay, I was originally gonna do what do you call it when you go abroad, a dialogue. And I was like, oh, can't apply to these REUs because I have my dialogue. Dialogue got canceled because there was a pandemic. So like, you never know. And it's like, it's not a binding contract. So it's better to like have all of those things on the table and then like make a decision with that knowledge.
And for like the virtual REUs, is that like a full-time job for those 8 weeks? Or is it like if you were doing a virtual one and you were at home, it's like not that big of a commitment? Or was it like a full-time job in a way?
Plan for a full-time job but I don't know if you've done a co-op yet. When you work from home, it's not always as productive as a full-time job in person. And so that's the level of commitment that your virtual learning is.
Basically, yeah, like, the amount of time that you spend doing like your research, staying focused on your work will really amplify what you get out of it. Like, because on online RU, that's very unstructured. Like, there's a lot of time you could like slack off or just like not make progress. And so it was the students that really put that time and that effort in when they like didn't have to, that they really got a lot out of it. So if you want to really like have an awesome amazing experience, yeah, put every effort in there. That being said, don't stress yourself out like staring at math all day gives you a headache.
Yeah, just a quick thing to add. I think most programs expect at the very minimum 20 hours a week. As a matter of fact, I actually did read that in my contract. If I'm not mistaken, there was a 20-hour minimum. So you should expect.
Thank you. And if I were to add to that, I think on my RU, I woke up at 10 a.m. every morning and work till like 4. So that's not like a full work day. But honestly, I was like, it's minimum 20 hours because like you just won't be able to do anything unless you put in that consistency and that practice. But if there's a day like you work 6 hours as a day, like nobody cares. It's more about you. But that being said, you can't do an RU and also take classes. Like that's just, you can't do an RU and also do a month of doing a co-op. Like there's just not going to be, you're going to be spread too thin.
Where can I find information about the co-op, the RU that Northeastern offers?
Yeah, so if you're on the Math Club emailing list, we will be sending all that information out. Logistics are still being finalized, which is why I had to be a little bit hand wavy when I talked about earlier. But everything should be live, like the application should be live within the next week or two.
The application deadline gonna be a little bit later than, since they haven't given us like details.
Yes, yeah, so it will probably be towards the end of February, that's due.
And if always, if anyone is not on our mailing list, you can join through the Engage page. We also have a Discord, so those are all ways to get in touch with us. You had a question too, right?
Yeah, mine was already like partially answered by Max with the undergraduate research department or whatever with Northeastern, but it was about like personal statements. So would you say that it's better to include like more about who you are and your own personal goals, or to include more like technical details, like I'm interested in this, and this, that is part of a project that the program is doing, or I have studied this, or I want to learn more about this? Like, what would you say is like the balance between personal details versus technical details to include in a personal statement?
Yeah. 1 or 2 people.
I'll be quick. So I lean a lot towards the technical side, and my view is that the personal statement is the place where you explain to a person running the REU why you would like to join the REU. And so some good things to say are, I am interested in this topic, maybe with aspects of your personal background. I'm prepared with the following coursework. I really hope that I can accomplish these goals, which should be relatively specific to the program. Right? I want to learn about graph spectral clustering and apply it to data science for a job. But those are the kinds of things that you should put in your personal statement. You should be a little careful to randomly add personal aspects if they don't support your reason to join the REU.
Questions? Anyone else? Anyone else, please?
Sick people.
All right.
I guess just to kind of add to what
Thank you.
he said, for kind of personal statements, yeah, try and keep it focused on the REU. Like, yeah, you could add a little like tiny blurb about yourself at the beginning, which is kind of what mine were, but you really want to stay focused, sell yourself as a good candidate for that. I have this background, I'm really experienced in this. I really want to learn more about this.
It's not a college essay
Yeah.
where you say, oh, you know, and then one day I was walking down the beach and nobody cares about that, you know? Like,
Yeah, it's not undergrad applications anymore.
Also, if I could give just like one piece of advice for writing a personal statement. If you can, get a second pair of eyes on it. Ask your friend, ask your teacher, ask like the Career Center, the Undergraduate Center to look at it. Because sometimes you stare at it and you think it looks perfect, and someone else is gonna come look at it and say, oh, I think it could be better organized this way. And you're like, oh yeah, of course. So, you know, sometimes you kind of need this fresh perspective to really enhance that. So I would highly recommend finding someone that you know that's experienced with that to help you out.
All right, Nick, now if you have to say something.
Okay, I had a question for one or two of you, but real brief answers. So I'm a freshman, I'm taking Calc 3 right now. And it sounds like all of your projects are like super technical, right? Super overly difficult. I'm a little bit concerned about being underqualified for these REUs. And what's something that you might want to say, yeah, in regards to that? Any thoughts, any suggestions? Can someone be underqualified to apply?
I wouldn't say you should apply for REUs in functional analysis in your position, but definitely there are math topics that are very accessible, graph theory, combinatorics. You really just have to know how to count and to draw pictures, and just have really solid algebra skills. So I think for those, you kind of want to more emphasize, like if you're applying to those, you want to emphasize your interest in mathematic research. You really want to like broaden your background. You have an open mind. You're ready to learn and put it to work. But don't be discouraged. There's lots of projects that are accessible for newcomers.
Another quick thing is that when I was applying, I do remember reading a couple for at least 2 programs that are actually focused on freshman students. So that's a good thing to keep an eye on.
Yeah, graph theory in particular is extremely accessible. Like you can know almost nothing about math. Like I feel like you could teach graph theory to an extent to an elementary schooler. So yeah, so if that's all that we have for questions, that pizza has been slowly cooling in the back of the room.
So another round of applause for all of our panelists.
Yeah.
Someone here can tell us exactly how much it's cooling.
Yeah, exactly. I want to thank you for all you 5 again. This was great. I think we covered a lot of information here. As sort of was mentioned, all this information too is on the Math Club Discord, will be on our mailing list. So if you are on that, you should have a lot of great resources there. But certainly if you have any questions at all, feel free to reach out to myself, to Sam, and you know, if you have any questions for our panelists, I'm sure I'd be able to put you in touch with them, or generally answer your question too. So yeah, so with that, as Sam said, pizza is fast cooling. The top box is vegan / gluten-free, and actually this time it should be vegan. We had an issue last week where it actually wasn't, but this time it should be. And then it's cheese pizza all the way down. So yeah, feel free to grab a slice or 2. We'll be here for a while longer, so like feel free to just hang out and eat. But if you have to go, you have to go. So thank you all for coming, and we'll finish it up.
The person in the Zoom call didn't want any pizza.
No.
Yeah. So all right, and if anyone here is applying to an REU, best of luck.
Yes.
We're all rooting for you. Fingers crossed. Right. That's the meeting.
Oh, yeah.